Okay, so we're told a 22 kilogram object decelerates uniformly, going from 2.5 meters per second west to a stop in 8.7 seconds. What is the net force acting on the object during this acceleration? So let's write out everything that we know. So we know the object has a mass of 22 kilograms. I know that it starts at 2.5, so that's VI. Now, you can set it to negative if you want your west to go negative, or you can just know that your west is positive. Which one do you guys want to do? You want to set west to negative? It's your choice. Or do you just want west to be the positive direction?
Yeah.
Let's just keep west as the positive direction. So we can have this as 2.5 meters per second. And it says it comes to a stop. So we know that its VF is 0. And the time it took to do that was 8.7 seconds. And we're asked, what is the F net? So if F net equals m times a, we don't have a, but we have a whole bunch of other stuff that could give us a. So what we want to think first is we figure out a by going a equals VF minus VI over t. So if you have to find a, you have to use your, so actually we are using quite a bit of kinematics actually in this unit. You have to figure out which acceleration formula do you need. Well, I had my VF, my VI, and my t. So my acceleration formula that works is this one. Once you have found a, then you can use this formula. So that's like our second step. So this is the first step, and that's the second step. I'm going to use actually red for number 2. Okay? So our first step, step number 1. So I'm solving for a, so I have 0 meters per second minus 2 meters per second, all divided by 8.7 seconds. So our a then is 0.2873 meters per second. Oh, and it's going to be negative, right? Yeah. Oh, and it's squared. Goodness sakes. Okay, so now we can do step number 2. F net is equal to m times a. So our mass, 22 kilograms, multiplied by negative 0.2873 meters per second squared. So we'll get negative 6.3218 newtons. Okay, so if you think about the question logically, the question says it's slowing down. So when we think about it, we have an object. It's originally, say, going, oh no, it said it was originally going west. Yeah, and since it's slowing down then, our F net needs to be in the opposite direction. So that makes sense that our velocity was positive, but then our F net is a negative. So that means, just like we said, that means slowing down. So our final answer then, we need to include our direction. So our F net, we need 2 sig figs, is 6.3 newtons, and what's its direction? East, the opposite of what it was before. Or the opposite direction as initial velocity. Yes. So, now you can do practice problems. I give you an assignment, and you can do questions 1 to 9.